Hi everyone, it's Mr. Hanscom. I'm sorry I couldn't be there today with you to teach this lesson and go over the homework, but I hope this video is helpful to you to get through things while I'm not there. First, I do apologize if I cough or you hear me need to clear my throat. That might happen a couple times during the video. Please pause this video and return to it if you haven't checked over the homework a little bit on your own, and you haven't done the do now from today on your own. I would like you to try it on just by yourself first, and then you can double check my little homework overview I'm about to do. And also, then we'll do the notes together so that you can pause and go back and complete 8-5 along with me. So, first thing is pause that if you haven't done it yet. Okay, but I'm going to go to the homework answer key now. All right. What we did on Friday is we continued talking about how to determine if two sets of values that are being compared are proportional in two ways. One is what you see on the screen right now from the homework, is just by looking at the table. But then new on Friday, we talked about how a graph also can show if something is a proportional relationship or not. So what we see right now is that the answer to is this table proportional? That's a yes. And that's because every single output value, every second value in the table, divided by every first value or input value in the table, 15 divided by 1, 30 divided by 2, and so on, they all became 15. So that means it's yes proportional. And that constant of proportionality is what that came out to be, 15. So that lets us create our y equals kx equation for this specific relationship, which is y equals 15x. Now, the other reason we would know, yes, this is proportional is because what you should have seen on your graph. Now, here's the scaling and graph that I got. You might have sized things a little bit differently, but I chose these numbers because it fit the 6 and the 90 on here, and it fit all the other points from the table on here as well. But it's proportional because it's a straight line specifically that hits the origin, 0, 0. So that's another way we knew all of this information came together to mean it was proportional. And so the point 460 up here above, we know what it represents because we go back to the table and we see that that constant of proportionality of 15 was saying 15 miles are how long or how far the bicyclist is traveling in 1 hour. So what 4,60 as a point would mean on the graph is that the bicyclist traveled 60 miles in 4 hours. So we can see that because the units were given to us in the table. On the back page of the homework, here was question number 2. Instead of asking if it was proportional, we know this one is because they gave us a unit rate to describe it. Frank's karate class is meeting 3 days every week. So after 1 week goes by, there were 3 classes. In 2 weeks, there were 6 classes because I can double that relationship. In 3 weeks, there's 9 classes because I take this relationship and I multiply it by 3 to find that value in the table, and I'd multiply it by 4 to find that value. And so y equals 3x would represent that, since 3 divided by 1, 6 divided by 2, and so on are all 3, the constant of proportionality. And then, once again, we have a table here. Okay, sorry, I don't know what those markings are from. Let me get rid of those. All right, but what we have going on here is a graph of the relationship showing us that it's proportional because it is a straight line hitting 0, 0. Okay, again, your graph might be a little bit different if you chose not to go up to 30 and not to go up to 10 on those axes like I did. It might have just a little bit of a different look, but it should still be a straight line hitting 0, 0. And this one is also y equals 3x. So even though it's 2 different scenarios, they actually had the same equation, and so they would have the same graph. It's just one is comparing classes for karate in weeks, and the other one is comparing cost to the number of video games that was rented. Alright, if you need to take another second look at that, go ahead and rewind the video, scrub back and get to where you need me to see it again, and talk about it again, but I'm going to move on past the homework to have you check the do now that you should have tried. So it kind of talks about the same things that we just saw in the homework, but here's the answer to today's do now. In the table, I just divided all of the values the y values divided by the x values, or the second parts of the table divided by the first parts of the table, and that is what you see right here. So I did all of that, and I got 7 every single time. So that meant it was proportional, and the graph also proves it as well, because this graph is a straight line that goes through 0, 0. So yes, it's proportional, and it's y equals 7x. Now what we're going to do today is we're going to analyze things in tables a little bit differently. Occasionally, some of these that we look at today might still be proportional, and so we might still end up getting graphs that look like this, straight lines that go through 0, 0. But other times, we might not get that. We might get straight lines that don't hit 0, 0. And that means there's a relationship between things, just not a proportional relationship. And so what I want you to see is that even though this question says, is the relationship a proportional relationship, explain why or why not, I'm going to spoil it and I'm going to let you know it's not. Because if I try to compare 5 divided by 2 to 9 divided by 4 to 13 divided by 6 and so on, these aren't equal. For example, 5 divided by 2 is 2.5. That does not equal 9 divided by 4, which is 2.25. And so these don't equal each other. And so we can already tell it's not proportional. But like I said a few moments ago, that doesn't mean there's just not some sort of relationship. So it still is going to have what's called a linear relationship. It's just not a proportional one. So the reason why it is not is there is no constant of proportionality. So let me show you how you can tell if something still is going to have a relationship that makes a line, just not a proportional one. And so I've taken this table of values, and if you flip to the next page in the notes, I've recopied that table of values here for you. So, as we can see, this says we cannot create an equation in the form y equals kx because it's not proportional. All right. However, we are going to be able to create a different equation from this. It's going to be something called y equals mx plus b. It's similar to y equals kx because it's a y value, a second thing in a table, equaling something times our x value in the first table, but we have to add something to it as well. And so the reason we can tell it's still going to have what's called a linear relationship is there's still a pattern, just not a proportional one. This pattern is that the x values keep bumping up by 2's. And that consistent increase, or decrease sometimes, but in this case an increase of those x's going up by 2 every single time, has something related to it as the y's go up. They're not going up by the same amount, but they are going up by a consistent amount every time. They're going up by 4's. So what that is called is, it's printed on your paper, a constant rate of change. So it's not a constant of proportionality, but it is a constant rate of change. So what we need to determine is that we can make an equation for this, but it's going to take a little bit of different work. So you can see there's 2 blanks down below. I want to describe what the variables m and b represent in the equation that we're going to use instead of y equals kx. 0, comma b represents the y-intercept, or, in other words, the answer for y when x equals 0. You might remember when we were graphing proportional things, we already always knew when things were proportional what the answer for y was when x equals 0. Because if I go back to the do now, when x was 0, y was also 0. We were hitting 0, 0 every time. But that's not going to be true anymore. M represents what's called the slope, or better known as the rate of change. And so today the lesson is for us to see how we go about determining the y-intercept and the slope. So there is a formula for these. Okay? First, let's talk about how we find the slope. The slope is known as y2 minus y1 equals x2 minus x1. And that comes from you using two different points or two different pieces of information from your table. And once we find this m value using this formula, you can then figure out b by substituting into y equals mx plus b. Now, practice makes perfect with these, so don't worry too much about this box that I just circled that in. I want to show it to you with action. So what I'm going to do is I'm going to pick two random things from this table of values, and I'm going to copy them down below as a point. I'm going to take the x value of 2 with the y value of 5, and then I'm going to take the x value of 4 with the y value of 9, and I'm going to bring them down here into this space where I have some workspace, and I'm going to go ahead and write them as 2 points, 2 comma 5 and 4 comma 9. And now I'll show you how you use this slope formula. So what we're going to do is we're going to take the two y values, the y value from the second point and the y value from the first point, and we're going to subtract them, y2 minus, oops, wrong thing there, y2 minus y1. And then we're going to divide that by x2 minus x1, the second x value with the second, I'm sorry, I'm misspeaking because I'm not feeling well, the second x value with the first x value. So we're going to do 4 minus 2. And so if you do 9 minus 5, you get 4. If you do 4 minus 2, you get 2. And 4 divided by 2 equals 2. Now I do want to show you that we could have gotten this answer of 2 for this m value a different way. I didn't have to pick those two values from the table. I could have picked any two values. So I'll show you that this would work with these two other values as well. I'm going to write those two things from our table as points down below. So I'm going to take 6 comma 13 and view that as a point. And I'm also going to take 8 comma 17 and I'm going to view that as a point. And now I'm going to try using this slope formula again, but with these numbers. So I'm going to take the second y value minus the first y value, 17 minus 13, and I'm going to divide that by the x2 minus x1, 8 minus 6. And when we do this, we get 4 over 2 again, which still becomes 2. So now we know for overall this table, the m value, or the average rate of change, is 2. And just so you know, you could have used any combo. So any of the 4 points, if you do this process, you would have gotten 2. Now what I'm allowed to do with this next part is find the b value, or the y-intercept. And to do that, I take the equation for a line known as y equals mx plus b, and I plug in the information I know. I know a whole bunch of x's and y's that work. I'm just going to pick any of the things from the table. So I'm going to pick a y value of 5 from the table, and that goes with an x value of 2. So I'll put those in. I also now know my m value. That was also 2. So I'm going to put that in. And that means the only thing I don't know from this equation is a b value. And so I can solve for this by doing the m times the x, which gives me 4. And I now solve for b by subtracting 4 from both sides, and I now know that b equals 1. And if I put these two pieces of information together, y equals mx plus b is now y equals 2x plus 1. Now again, practice will make perfect, so the more we do this, the more it will make sense. But if you want to re-watch that part, that's not a horrible idea, so you can go ahead and do that. But I'll just show you how this works with new tables, so that hopefully you can get a better idea. So I'm going to pick for this table any two values, and this means we're going to be able to make an equation that will represent how we can find the cost of renting a bike based on how many hours you want to rent it. So I'm going to pick two random spots from the table to show you it could be any two. I'll pick this one and this one. We're always going to view the starting value of our tables as our x's, the ending values, the second row or column, as y's. And now I can do y2 minus y1 over x2 minus x1. So my y's are going to be 40 and 30, so I will subtract those. And my x's are going to be 4 and 2, and I will subtract those. And so for this, I will get 10 over 2, or 5. So now I know that that's 5. I will then go ahead and take any of these points. I'll just pick this one at random, and I'll use that point in the equation y equals mx plus b to figure out the b value. So I'm taking this point from the table, and I'm taking my m value that I just found, and I'm putting them into this. So I'm going to take 35 as a y, 5 as my m, 3 as my x, and I'll find b. So 35 equals 15 plus b. So if I subtract 15 from both sides, 20 is my b value. And I can get an equation, y equals 5x plus 20. Now what that means in real life is we know that it's going to cost us $5 an hour to rent a bike, but no matter what, they're going to already have charged someone $20. So if they ride the bike for 1 hour, it's the $20 fee plus just $5, and that's making $25 in the table. $20 fee plus 2-hour rental, or 5 times 2, would be $20 charge plus 10, and that's making $30. And so while it's not proportional, it's still a relationship. Okay, if we look at this one, this table below shows the cost of renting a boat instead of a bike. So let's see what the boat rental costs compared to the bike rental that we must have just figured out. So I'm going to do y2 minus y1 over x2 minus x1, and I'll just pick the first ones I see this time. So 27 minus 9 over 3 minus 1, that becomes 18 over 2, or 9. And so now, if I go ahead and use that information, I can solve for b. I'll just pick the very first point, put 9 in for y, put 1 in for x, and I'll take my slope I just found and I'll put that in. And so I get 9 equals 9 times 1 plus b, or 9 equals 9 plus b. And when I subtract 9 from both sides, I get b is nothing. b is 0. And so that actually creates y equals 9x plus 0, or just y equals 9x, which you might recognize is actually the equation y equals kx. So sometimes when you use y equals mx plus b, it will actually give you a y equals kx equation, and we've just discovered another way to see if something is proportional. So while our last problem we just did had y equals something times an x and then plus or minus another number, and it wasn't proportional, this boat rental place is actually using a proportional relationship, meaning it would hit 0, 0 if I graphed it, or meaning if you don't rent a boat, then you don't ever get charged any amount of money at all. Alright, so let's actually see a graph of one of these. So if I go ahead and I do this process, we're going to finally see a non-proportional relationship that's still a line. So when we finish this one with this graph, we're going to see a straight line that doesn't hit 0, 0. So it's not going to be proportional, but we'll still be able to write an equation for this. So what I'm going to do is I'm going to take the table of values and I'm going to very carefully add these as dots to my graph. So on the x-axis I'm going to have 1, and on the y-axis I'm going to have 9, so I'll put a dot there. And then for 2 I have 10. And then for 3 I have 11. So I'll go to 3, 11. And then 4 I have 12, so I'll track up and find where 412 is. And they're all lining up. So if I go and take a straight edge, what I can do is now connect all of these dots and notice that there's been a pattern to them. They do connect with a straight line. It's just a straight line that doesn't hit 0, 0. And so that's the line that everyone should get if you graphed it along with me. And what we'll be able to do is we'll be able to find an equation using the techniques we just learned. So I'm going to take my first two things as points, and I'm going to do that slope equation, that m equation, y2 minus y1 over x2 minus x1. And so that's going to give me 10 minus 9 over 2 minus 1, which becomes 1 divided by 1. Or our m value is 1 in this situation. And then what I'm going to do is take y equals mx plus b. And I'm going to figure out b by putting in 9 for y, 1 for x, and my 1 for m. And I get 9 equals 1 plus b. And if I subtract the 1 from both sides, 8 equals b. And so my equation would be y equals 1x plus 8. Now if we read question C, it says use your equation from part B to find a corresponding y value for an x value of 20. So what we would be able to do with this is take y equals x plus 8 and put in an x value of 20 and see what would happen. And I would now know y would equal 28. Okay. So remember, if you ever need to, what you can do is you can go back to any of the things we already looked at and try those problems again. I'm just going to kind of go quiet and I'm just going to model the last two on these notes for those of you that have gotten to these. And you can just kind of follow the screen and maybe use my silent work as some practice problems for you, or you can pause the video, try them on your own, and then come back to this. So I'll go quiet right now in case people do want to try it, but pause it also if you want to have some extra time to do it, and then restart the video and see what happens on the screen. Okay, if you reached this and hadn't checked your answers to the problems on the very last page, they are completed on the screen. If you have all of this done, the substitute should be able to get you a homework sheet on this topic.